Dear students, in this video we are going to study about the thermoelectric effect such as Seebeck effect, Peltier effect and Thomson effect. Now let us study about the thermoelectric effect. What is the thermoelectric effect? It is the conversion of temperature differences into electrical voltage and vice versa. That is called as thermoelectric effect. A thermoelectric device generates voltage when there is a temperature difference on each side. If a voltage is applied, it generates a temperature difference. There are three effects. The first one being Seebeck effect. Seebeck discovered that in a closed circuit consisting of two dissimilar metals, when the junctions are maintained at different temperatures, an EMF is developed. The current that flows due to the EMF developed is called thermoelectric current. The two dissimilar metals connected to form two junctions is known as a thermocouple.
Hi, I am Thomas Johann Seebeck. I now tell you about the Seebeck effect. I discovered that in a closed circuit, consisting of two dissimilar metals when the junctions are maintained at different temperatures and EMF potential difference is developed. The current that flows due to the EMF developed is called thermoelectric current. The two dissimilar metals connected to form two junctions is known as thermocouple.
So this is the diagram of Seebeck effect, which is observed in a thermocouple. This is a thermocouple having two dissimilar metals, copper and iron. In this copper and iron junction is kept as cold junction, and here iron and copper junction is kept as hot junction. Therefore, a current will flow through this thermocouple. If the hot and cold junctions are interchanged, the direction of current also reverses. Hence, the effect is reversible. The magnitude of the EMF developed in a thermocouple depends on two factors. One is the nature of the metals forming the couple, and the second one is the temperature difference between the junctions. Let us now see the applications of Seebeck effect. Seebeck effect is used in thermoelectric generators called Seebeck generators. These thermoelectric generators are used in power plants to convert waste heat into electricity. This effect is also utilized in automobiles as automotive thermoelectric generators for increasing fuel efficiency. Seebeck effect is used in thermocouples and thermopiles to measure the temperature difference between the two objects. Next, we will study about the Peltier effect. In 1834, Peltier discovered that when an electric current is passed through a circuit of a thermocouple, heat is evolved at one junction and absorbed at the other junction. This is known as Peltier effect.
Hi, I am Jean Charles Peltier. I now tell you about the Peltier effect. I discovered that when an electric current is passed through a circuit of a thermocouple, heat is evolved at one junction and absorbed at the other junction. This is known as Peltier effect.
So here, these two metals, they are joined together and their junctions are kept as cold junction and hot junction, and an EMF is given, thereby allowing electric current to pass through the circuit of this thermocouple. So in the copper iron thermocouple, the junctions A and B are maintained at the same temperature, but a current from a battery flows through the thermocouple. At the junction A, where the current flows from copper to iron, heat is absorbed and the junction A becomes cold. And at the junction B, where the current flows from iron to copper, heat is liberated and it becomes hot. The direction of current is reversed. The junction A gets heated and the junction B gets cooled, as shown in this diagram. Next, we are going to study about the Thomson effect. Thomson showed that if 2 points in a conductor are different temperatures, the density of electrons at these points will differ, and as a result, the potential difference is created between these points. This Thomson effect is also reversible like the Peltier effect.
I'm J.J. Thomson. I now tell you about the Thomson R effect. I discovered that if 2 points in a conductor are at different temperatures, the density of electrons at these points will differ, and as a result, the potential difference is created between these points. The Thomson effect is also reversible.
There are two types of materials available which exhibit positive Thomson effect and negative Thomson effect. If a current is passed through a copper bar AB, which is heated at the midpoint C, The point C will be at higher potential, and this indicates that the heat is absorbed along AC and evolved along CB. So in this region heat is absorbed, and here in this region heat is evolved. Thus heat is transferred due to the current flow in the direction of the current, and this is called as positive Thomson effect. This positive Thomson effect is observed in metals like silver, zinc, and cadmium. So the copper bar is replaced by an iron bar, as in this diagram. Heat is evolved along CA and absorbed along BC. So here in this region heat is evolved, and here in this region heat is absorbed. Thus heat is transferred due to the current flow in the direction opposite to the direction of current, and that is called as negative Thomson effect. This negative Thomson effect is observed in metals like platinum, nickel, cobalt, and mercury.